Welcome to Valley's Gold, a show where we explore the people and places who feed and clothe us. On this episode, we're learning about the production and usage of electricity in the California agricultural industry. Please join me, Ryan Jacobson, on this adventure.
Valley's Gold is produced through a partnership between the Fresno County Farm Bureau and Valley PBS. Production funding for Valley's Gold is provided by
the Myers Water Bank and Wildlife Project, an educational outreach program working to teach students about water and wildlife issues in California. Field trips are free for all schools, and each trip's curriculum is based on learning about California water resources, valley agriculture, and native wildlife.
Everyone enjoys getting together to laugh, to talk, and mostly to eat. It sounds so simple, but the reality is that it takes a lot of hard work to feed us. The next time you sit down to eat, remember to thank our farmers, Gar Tutelian Incorporated since 1949 at 800-696-6108.
Heroes come in all shapes and sizes. At Brandt, our heroes are the men and women in the field, the folks who work hard to put food on our table. Join us in celebrating the Valley's real heroes. Brandt, professional agriculture.
I'm super excited to be out on a gorgeous day out on the lake.
It is a beautiful day. So
And it's very pertinent when we're talking hydropower. But before I get there, let's talk about PG&E. What is PG&E?
Well, Pacific Gas and Electric. It's one of the largest investor-owned utilities in California, delivering gas and electric power to customers, agriculture, and in this case, helping deliver water.
Okay, and in your case, what's your background with PG&E?
I've been with PG&E 32 years. Started out with hydro operations back in remote camps along the Kings River. Primarily been in hydro operations and maintenance most of my life in the career. Instructor at the school, what have you. So I've a well-rounded career in PG&E.
Got it. So you're saying the hydro. What is hydro?
Well, like you mentioned on the opening, hydro power has been around for thousands of years. If you just look at a paddle wheel or flowing rivers, starting to harness that power. So hydroelectric is hydroelectricity. So we're just using water power to make electricity. So all the way from basically your northern border, Shasta area, all the way down to Kern.
And the one thing I was impressed with is that, I mean, we're talking dozens of facilities up and down the state.
Yes.
But no two are really the same. I mean, everything has to be done project specific.
Yes, and then the history of that evolution speaks to that. Yes, hydroelectricity really started coming out in the mid to late 1800s in itself. The boom in California from logging industries to gold rush to agriculture started kicking about the same time. So we have some of our older facilities dates back to that era, late 1800s, early 1900s. The plant right below this dam, 1905 or so vintage, all the way up to the 80s where we have our Helms project, Kirchhoff project. I've been across the country, opportunity to go across the country looking at other applications. The Sierra Range is like no others. You have all the height of the mountains, the Sierra Nevadas from one end of the California to the other, tremendous amount of rivers and watersheds, which makes it right for hydro applications. And that elevation and the snowpack really allows us to pace that water delivery out and create more pressure. And the more pressure you have for our hydro applications, the more efficient, more power you'll get out of it.
Yeah, exactly. And it's one of those, I guess you would say, quiz questions I always like to tell people when they talk about what is the largest reservoir in California, and you talked about it. It's that snowpack.
Yes.
I mean, we think of actual lakes, but that snowpack allows us to have that constant water delivery over a much longer duration than what you see in other parts of the country.
Great point. And Mother Nature kind of changes that delivery, hotter days, what have you. But we work with a cooperative manner with a lot of different agencies to go up and gauge the snow. That helps you predict that reservoir, that frozen reservoir, how much water is going to be up there, when potentially it could come down, and how we can manage it for hydroelectric and delivery to the irrigation communities and water deliveries for the communities. Well, real typical, large reservoirs. We start harnessing that water, delivering it to the turbines, generating electricity all the way down to the San Joaquin River in this case. And then we have more facilities along the San Joaquin River, and then that delivers it into Millerton. So that water is used over and over and over to generate electricity that goes into local communities, into the bigger grid.
And there's a real science to this. I mean, these turbines are, I mean, it's very calculated, the rotations and what's being done to generate that electricity.
Oh, you bet. There's a lot of engineering goes into it, the speed, and based on how much water pressure is available to it, really dictates the design of those. And then we try to manage the water. And so the canal system, water conveyance, and everything also is matched with typical snowfalls and, you know, rain and precipitation for that area. It's all kind of matched up. That is a critical part. A lot of your renewables, wind farms, hard to predict. Even the sun with cloud cover is a little more volatile, but hydro with the snowpack calculations we have, is a little more calculated on when we can deliver it, and especially with our larger hydro, it's more, you know, sustainable for the grid overall. And the delivery of that water, the conveyance system, the aqueducts, everything that came from that all starts with the dams and the reservoirs up top in the Sierras.
Got it. So out of all the projects that we talk about up and down the state, they all have that little bit uniqueness. But there's something special about the Helms project that I wanted you to tell me a little bit about.
Well, Helms, the biggest feature for today's world is the pump back capabilities. So they can act as typical hydroelectric generation during the day. When there's abundance of solar in the day, we can turn those large turbines around, pump the water back up to the upper reservoir, and get ready for the evening peak. So twice a day, we're hitting the peak in the morning, solar takes over, and then we could pump using that power, and then the evenings, we're hitting that peak again, keep everybody's power lights going. Oh, you bet, especially in the foothill communities. You know, just the town of Auberry, you have Southern Cal Edison with Big Creek and their hydroelectric on the San Joaquin River, ourselves, Kings River, but up and down California.
And Paul, for our viewers that want to learn more about PG&E's hydro division, where can they go?
Well, of course, pge.com has a lot of information on there. The history of hydro goes way back in California, and utilities, PG&E has been a part of that all along.
Absolutely. Well, Paul, this has been awesome to learn about this incredibly important resource we have right here in our backyard. And like I said, the connection between agriculture and these hydropower facilities is very strong, and it was great to come out and see it today.
My pleasure, thank you.
Appreciate it. Once generated, electric power must be moved from where it's created to where it's needed. We're in Central Fresno to learn about the transmission process from Steve Rowland of PG&E. Well, I'm excited to learn about this incredible place, but before I jump to that, tell me about your background and your experience with PG&E.
Okay, 39 years with Pacific Gas and Electric. Experience ranging from, started out in hydro, which you visited already, okay. Migrated to the transmission side of the house, and then have landed, if you will, in the distribution side of the house. So kind of all the elements that you're speaking to are within my background in some form or fashion.
Which is fantastic because we did just come from the hydro project, but we saw how that energy was created, but now we need to see how it's moved. And that's what you're the expert at. So let's begin with this building here. What exactly is it utilized for?
Said it's state-of-the-art, and it's part of our grid modernization project and part of the smart grid. We migrated from what we'll call paper on walls with pins, cork pins, to electronic mapping that we can operate amongst ourselves. Each station's capable of supporting each other. Yes, this center currently controls the area from basically a Lodi in the north to the Coast Range. Okay, we'll call it the east side of the Coast Range, to the Sierra Nevada to the Grapevine.
Got it, okay.
On the distribution side.
And when we talk about that energy that's being moved, we saw it being sourced up in the mountains and it makes its way down, particularly here, we're talking the valley floor. What is that process? How is it moved? And can it be stored or does it need to be used almost instantaneously?
So typically it's generated, goes through a transmission system, and then it arrives in substations to where we take it at the distribution level, we call it, and then dispense it through circuitry to people's homes, their businesses, their farms. We have what's known as SCADA, which is supervisory control and data acquisition, but basically remote control. What that function does for us allows us to control, manage, monitor the electric system from these terminals within this building. With that, we're able to identify if there's a power outage or a voltage issue, and then address it remotely or dispatch field personnel as needed to be able to address the issue. So that group is responsible and does a fantastic job of interacting with not only the National Weather Service and other agencies, but they develop their own forecasts. So be it a storm that's coming, they identify and actually have a predictive model to tell us where we can expect the problems to be and how significant they could be, which allows us to migrate resources, field personnel, et cetera, crews into hot spots ahead of the storm. Well, PG&E is a member of the WEC, which is the Western Electric Coordinating Council. That's comprised of 13 western states.
Wow.
Including a couple of provinces in Western Canada and even a little bit of Baja California.
Got it. The reason why I'm here is the industry that's near and dear to my heart, agriculture. There is a very important role that PG&E plays in this industry.
Absolutely. PG&E is obviously customer driven. Okay, of which ag is definitely a large customer to PG&E as an aggregated basis. So we have a tremendous responsibility to that industry to sustain them as best we can with clean, affordable energy.
So I guess the one takeaway from all of this is the fact that the San Joaquin Valley agriculture industry does a lot to feed the world, and PG&E is a major partner in doing that.
I would look at it from this perspective. Everything we can do to safely deliver clean, reliable energy to our ag partners is our primary mission.
Well, Steve, thank you so much for sharing this incredible facility. It's really a important piece that a lot of people just don't get to see. You turn on the switch, you get the light, but they don't know everything that goes into the backstory of it, and there's a lot that needs to be done to make that happen.
Absolutely.
Yeah.
It's really nice to have you here.
Water is the lifeblood of agriculture, but for farmers to utilize that water, they need to take it from where it is to where it's needed. We've been joined by Harold Harris of PG&E to learn more about pumps and irrigation. Well, I'm happy to have an expert on an extraordinarily important issue, and that's pumps and irrigation. This valley doesn't do what it does without water, and so before I jump to that, can you tell me about your role with PG&E?
Yeah, I'm what they call an agricultural account rep. So I work up and down the valley and up in Northern California too, but strictly with agricultural customers on rates, rebates, promoting energy efficiency on the farm itself. Oh yeah, for the whole state, it's about 20% of all the energy within the state goes to the movement of some kind of water.
Really? That's amazing.
So you got surface water coming down the canal systems, or you got deep wells lifting it out of the ground. But yeah, 20% is a huge number of the electrical usage in California. Well, in this particular case, it's got an electric motor on the top, and so it's spinning, and it drives a shaft, which in turn spins the pump down in the hole, and that pump is lifting the water up to the surface, and then actually pressurizing this system here through the filtration system before it takes it out for delivery to these micro sprinklers.
Yeah, and these micro sprinklers are then feeding these incredibly important crops we have here in the valley. And this system we have in back of us is I don't want to say a newer system, but there is a specialness to it. What makes this system so special behind us here?
Well, along with having a nice irrigation system, it has what they call a variable frequency drive on it. So in this particular case, he can slow it up or speed it down and deliver different amounts of water depending on what kind of a set he's got set out in the field. So he's not locked to one speed or one flow rate. He can vary that by varying the speed of the pump itself. It's 1 kilowatt hour to lift 1 acre foot of water 1 foot at 100% efficiency. And so what we do is we try to measure the pump's efficiency to give the customer that number, because nothing comes at 100%.
Yeah.
But
there could be a substantial difference from 90 or 85% down to probably pumps that probably go down to 40, 50%.
Oh yeah. So we're trying to catch them as they wear. The efficiency drops off. So what we're trying to do is catch that at the optimal time to make a repair to that pump, and then bring it back to its the most efficient portion as it can. Yeah, we have actually our oldest energy efficiency program was started in 1923, and that was the pump testing program, and it was basically going up and down the state and measuring the pumps and seeing what the efficiency is of those pumps.
And a lot of it is just repair work that needs to be done, but in the end, it's going to save you a lot of money just because of less energy usage.
Yes, that's correct. We have the pump testing program, which actually subsidizes the test itself. And then we have a repair program that's run through Fresno State, APEP, Advanced Pump Efficiency Program, that if you do need to make a repair, it helps you to help fund that repair and get everything back up in top order. Yeah, there's you know, for dairies we got fans, VFDs on fans. It's kind of just like a pump, but it's just moving air. And so we have VFDs for fans. We got lighting rebates. If you can think of it and if it saves energy, we can probably figure out a way to get you some money back. During different parts of the day, the energy costs are varied greatly depending on what kind of generation we have on the system. So typically in the middle of the day to late evening is our most expensive time, and that's when there's a lot of competition for that energy use. It's not just time of use rate, but there's also some demand response programs that can work to your benefit too.
Well, great. So where can our viewers go to learn more about these programs?
Well, we have pge.com/ag, or you can contact the Ag Hotline, and that number is 1-877-311-3276. And that's a great number. It goes straight to a person, and you don't get caught up in a a revolving door type thing.
So you're able to get any of your energy efficiency answers directly
from a human being. So.
Well, fantastic, Harold. I appreciate this incredible information about, as I said, something that's so important to this industry. Agriculture doesn't exist without water application, and water application doesn't happen without energy. So really thank you for explaining this whole process to me.
Well, it's a pleasure being here, and thanks for having me.
Solar is widespread throughout California, including many farms and ranches. We're near Chowchilla to learn about this not so new but increasingly popular technology. Our guests include Mike Williams and Jeff Gatzka of Pickett Solar. I'm excited to be out here to learn about this awesome technology. Before I jump to that, Jeff, tell me about Pickett Solar.
So Pickett Solar is actually a part of Don Pickett and Associates. The Pickett family's been in construction in the Fresno area since 1972. We started Don Pickett and Associates in 1988, and Pickett Solar is started in 2008.
Got it. And you've been there since the beginning, right?
I have, yes. Don actually sent me off to get some training and learn about solar to put on our construction buildings that we were building, and we just really haven't looked back since.
Got it. And Mike, how'd you join the company?
I basically got to see the passion that these guys had, what they were doing, and I was recruited in about 4 years ago. And we've been running non-stop since, and it's great to work with these ag guys to help them out.
So what solar, everyone calls solar, is actually photovoltaic electricity, or PV. It's the transfer of sun energy into electrical energy that we can use in our toasters and things at home, or to run ag pumps, or a multitude of different things. So these solar panels actually track the sun throughout the day. We get about 20% more performance out of a system such as this, as opposed to a fixed system.
Got it. Okay. Mike, there's different types of solar. What are those?
Well, basically, like Jeff said here, this is a single access tracker, but other options are rooftop installations. There's solar structures, which are referred to as carports. Those are probably your 4 biggest ones you'll see. We have the most expensive power out here. 30% above the national average is our cost of electricity, and ag clients actually pay even more than that. So by being able to do this, they can actually take back some control of their power costs again.
Got it. And Jeff, I talked about this not being a new technology. Solar's been around for quite some time.
Yeah, some of the patents actually date all the way back to the 1800s.
Oh, wow.
Believe it or not. But I think really the solar industry as a whole kind of took off with the space program. In the 50s and 60s, with space exploration, satellites and things like that, solar panels were a big way to get energy for those electrical needs. Radically come down is a good way to put it. Yes, it's a lot cheaper today than it was in the past.
And you still have tax credits that are still active through the next few years, so that really helps them become a no-brainer.
Yeah. Besides the fact of energy cost, I mean, the weather and the climate here is just perfect for solar.
So the sun doesn't hurt.
Yeah.
We definitely like a lot of sun. The cooler the better, but we can definitely make use of all sunlight and all different ranges of temperature. So usually the customers will bring us their utility bills to review, see what kind of usage they have, figure out how much solar they actually need. From there, we design a system located on the property and let the owner decide if it's a good spot for them. Being close to utility power lines, that's a positive thing as well.
But every system, I would say, is custom. There's no cookie cutter. Everything's designed for what's best going to fit your needs.
Absolutely.
So here we have what's considered a 1 megawatt DC size system. This is a single axis tracker, so it tracks the sun throughout the day, and it offsets approximately 40% of the customer's electrical needs here at this particular facility.
And this tracker's producing probably 2.2 million kilowatt hours roughly
right around
annually.
there. Mm-hmm.
That sounds like a lot. What does that mean?
So your average home is about 8,000 to 10,000 kilowatt hours a year. This is 2.2 million.
Oh, so it's a lot of homes.
It's a lot of homes. So the utilities around here have a system in place called net energy metering. It allows you to aggregate a number of different meters together and do one large solar array.
Got it.
Yeah, and you can go, basically you can have one array on a site and offset many pumps as long as your land's contiguous for as far as you can go.
And that's important because, I mean, like I said, a lot of farms have multiple meters, and it wouldn't make economic sense to have a lot of different
Traditionally, up until a few years ago, it was small arrays at every single pump, and that just did not make sense. This has truly made it even more of a no-brainer.
Our viewers that want to learn more about solar, where can they go?
We love to talk and we love to educate, so please feel free to give us a call, email, go to our website.
Well, thank you guys for sharing this incredible information about this very important resource for farms and ranches up and down the valley.
Thanks for coming out, Ryan.
Thank you for having us. We really appreciate it.
Thank you. I hope you've enjoyed our electrifying time together exploring California's agricultural and energy industries. Please join me again for more Valley's Gold.
Valley's Gold is produced through a partnership between the Fresno County Farm Bureau and Valley PBS. Production funding for Valley's Gold is provided by
the Myers Water Bank and Wildlife Project, an educational outreach program working to teach students about water and wildlife issues in California. Field trips are free for all schools, and each trip's curriculum is based on learning about California water resources, valley agriculture, and native wildlife.
Everyone enjoys getting together to laugh, to talk, and mostly to eat. It sounds so simple, but the reality is that it takes a lot of hard work to feed us. The next time you sit down to eat, remember to thank our farmers. Garge Italian Incorporated since 1949 at 800-696-6108.
Heroes come in all shapes and sizes. At Brandt, our heroes are the men and women in the field, the folks who work hard to put food on our table. Join us in celebrating the Valley's real heroes. Brandt, professional agriculture.
Valley PBS is committed to teaching children the importance of agriculture. Valley's Gold Education through Agriculture offers lessons for elementary school students. To download free worksheets and activity kits, and to watch child-friendly videos about the crops explored on Valley's Gold, visit valleysgold.org and click on Education.